great. Why doesn't adding to both sides make any sense? Will that get rid of squared? No. Okay, and that's because adding is not the blank of squaring. Inverse, yes. So the big idea of this problem is not just to see if you can do pre-algebra. It's to remind you that when you solve an equation, you use the inverse function. In a squaring case, the inverse is square rooting, and there is that wacky plus or minus. The inverse is squaring is square rooting. Now, cool. Today, we're going to talk about exponentials and logs. What's the inverse of logs? Inverse of log is exponential. All right, so how do we get rid of log base 4? 4 to the, and whatever we do to one side, we do to the other, so x is 8. Now all that's review. Now let's go on to the new ones of the day. So you've got these exponent problems, and we're going to have to figure out x. So we want to undo. What undoes 10 to the power? By log. Log base what? 10, okay? But whatever we do to one side, we have to do to the other. So we're going to do log base 10, which is called common log, equals log base 10 of 8. The idea of math that you've got to do the same thing on both sides doesn't change. It's still there. Got to do both. You with me? Okay. So what's on the left side then? Negative 2x plus 2, like a floating exponent with no base, or it's a normal negative 2x plus 2 written big. Normal negative 2x plus 2, all big, yeah? Okay? Now, log base 10 of 8 is ugly. I would love it if you could tell me it's about what? Log base 10 of 8 is about 2. That's a terrible guess. Let me try again. 3 is even worse guess. Right?
1.47.
Okay, there you go. What is log? So it'd be great if you could tell me, what does log base 10 of 8 mean? 10 to what power is 8? So let's fence it in. 10 to the first is 10, and 10 to the 0 is 1. So it must be between 0 and 1. I typed into my calculator, between 0 and 1. Right? You down? Okay, cool. Now that said, I'm going to type into my calculator later. I'm going to keep working and finding x. Kane, what would I do next to get x by itself?
Add it or subtract 2.
Subtract 2. Beautiful. Negative 2x equals negative 2 plus log base 10 of 8. I recommend you write that negative 2 in front of the log. If you write it after the log, people tend to put it in the log argument. That's bad. So I like to write my stuff in front of the log. All right? Last but not least, Katie, what next? Divide by negative 2. That is going to be my answer. Now, would you pick up the old calculator and let's practice putting this in our calculator, or come and get a calculator. Negative 2, maybe negative 2. Now, if I'm going to divide, if I have a sum in the numerator denominator, what do I have to do before I put that into my calculator? This is something, right? Yes, there you go. See? You want to put in parentheses so that it's just not the last thing you divide, but all of it. So start with some parentheses, and then give me negative 2 plus maybe. How do you get log? Log base 10 is actually right there. You see that guy right there? That's log base 10. And I guess it's asking me for the base anyway. What's in there? 8? 8. And then I want to close the parentheses, divide by negative 2. And I got 0.5848. You cool? All right. Just to check your working kind of thing, and because it's good practice, you'll often in calculus need to store a number. So would you see that? Are you stored before?
Yeah.
Okay. So would you store that to A? All right. Oops. I have something else in there from my previous class, so I'm going to call that G. Okay, or something in G2. I should have just scratched everything I already had. Does anybody know what I haven't used yet? Let's go C. H, here we go. Let's go to the back end. Let's go S. Who would use S? Ah, so cute. Q? Maybe I just should.
Because the answer is error can always change.
Did I not get a numerical answer?
Your answer is error can always change.
Oh,
Very good.
I got you. Okay, there we go. Store that to U. Yeah, yeah. All right. Boom. Okay, now I forgot what it was. What was it again? 548. Okay. Now these should never be missed on a test because I can easily check with 10 to the negative 2, whatever you called it, a plus 2, hit enter, and if it doesn't equal 8, then you really blew it. So if I go 10 to the negative 2a plus 2, 10 to the negative 2, what did I call it, u plus 2, boom, 8, we're good to go. We should know right away whether we did this well or not. You with me? Okay. Now, let's try number 4. Same idea, but slight difference. What shall we do now to get x by itself?
Natural log.
Yeah, the opposite of e to that is natural log. Whatever you do to one side, you do together. Make sure you show that. What's the left side become? Normal negative 2x plus 3, and the right side is log of 5. Log of 5 is probably about 2, between 1 and 2, because e to the first is 2.7-ish. So it's about 1 or 2. All right, now what do I do to get x by itself? China, what do I do next to get x by itself? Subtract 3. So negative 3 plus log of 5. I don't know if you need to show it under, or you could just write what you're getting each time as you do something, and then your final answer is negative 3 plus log of 5 over negative 2, yeah? Plug that into your calculator, please. I'm going to start from scratch. Or not. So, what is it? Negative 3 plus log of 5. How'd that turn out? Good. Plus log of 5. Close the parentheses. Divide it by, what was it again? Negative 2? Okay. Okay, does it get 0.695? And again, you could check that if you were so inclined. Did I say negative or 0.695? Okay. All right. So far, so good?
Yes.
All right. Little wrinkle here. So we definitely want to get rid of the e, but do we get rid of the e first?
No.
What do we get rid of first? Yeah, you have to work outside in. So you're going to get rid of the 6 first and get 2/3 equals e to the 2x plus 3. And then you do what? Natural log of both sides. So natural log of 2/3 equals 2x plus 3. Let's just do the last 2 changes at once. So what do you do to get x by itself after? Subtract 3, divide by 2. So the log of 2/3 minus 3, all divided by 2. Punch it in your calculator. Log of 2/3. What was it? Minus 3 divided by 2. 3 divided by 2. Now you get negative 1.7027.
Yes.
Okay, negative 1.7027. Again, we can store that and check it if we were so inclined, and we should on a test. All right, last but not least, or actually maybe not last. So this one's where things start to get wacky. Because obviously you have x's and exponents on both sides. Now you have two choices. What two things could we do? What are two things you want to get rid of? The 5 to the, or the 6 to the. So we have two choices. What are they? Log base 5 or log base 6. Now both are mathematically sound, but in terms of how we're going to express our answers in the class, we're always going to solve for the left one. In these cases of x on both sides, log choice based on the left side. Okay, that way we can all have kind of the same answer to look at. The number would be the same either way, but on no calculator problems, you're just going to leave your answer in terms of logs, and so we want ours to be the same everywhere. So we're going to take 5 to the 2x minus 1 equals 6 to the x minus 2, and we're going to say I want to get rid of the 5 to them. And whatever I do to one side, I do to the other. All right, now the left side is going to be peachy. What's the left side? Just 2x minus 1 because the log and the exponential go away, right? The right side, not so peachy because log base 5 and 6 to the power, those are not inverses, yeah? All right, this goes to a little bit of log rule action. Do you remember your log rules? Okay, here they are to remind you. This is the one that's going to be applicable here. This has natural log, but it's true for all logs, not just natural log. If you have an exponent in a log, that exponent can be brought down out front. So, when we look at that problem where we left off, I have a log of something with an exponent. That exponent can be brought down front. 2x minus 1 then is equal to, in parentheses, x minus 2 log base 5 of 6. What's log base 5 of 6? Between, right, 1 and 2. Because 5, log base 5 of 5 is 1. Log base 5 of 25 is 2. Okay, so that's 1 point something, but just trying to make you think. All right, but my point is it's a number here. It's not a pretty number, but it's a number. So, what now? Yeah, we want to get some x's together. Maybe we should distribute first. Let's call this log base 5 of 6x. And I'm going to put that log base 5 of 6 in parentheses so it doesn't look like that x is inside it. Minus 2 log base 5 of 6, which is just a number. You cool? Now think here. What if you had 2x minus 1 equals 5x plus 3? What would you do? You get the x's on one side and the numbers on the other. Same deal here. We want the x's on one side, the numbers on the other. So let's move this guy over. It becomes 2x minus log base 5 of 6x, yeah? Let's move the plain old numbers to the other side. So what does the right side become when I move the 1 over? 1 minus 2 log base 5 of 6. All right? We're almost there. I want it. So what can I do now to get x separated out from all this stuff? Factor. There's a greatest common factor of x. If I take out an x, I have 2 minus log base 5 of 6 out inside, and the right side's not going to change. So x then is 1 minus 2 log base 5 of 6 over 2 minus log base 5 of 6. Now this definitely needs to be practiced. That's not easy to put in your calculator without error. So I want you to practice it Put that in your calculator. I strongly encourage you to use parentheses, or actually, maybe we should use the fraction template. What do you think, huh? Should we start by making a big old fraction? Okay, so I'm gonna cross that out. So if you go right there above the division sign, I believe, there's a big old fraction. And in the top, we're gonna put something. 1 minus 2 log base 5 of 6. 1 minus 2 log base 5. This is so much easier now. You have no idea. You used to have to convert the base in an old calculator. 2 minus log base 5 of 6. 2 minus, shoot. Did not mean to hit that. Do. 2 minus, sorry I'm slower than you. You're young and speedy. Did you get an answer of negative 1.383? Yes, would you store that and check it, please? Practice storing that and checking it. Store it to something. H. And check your work. Negative, we did a lot of steps there. We want to make sure we did it right. Negative 1.383. Negative 1.383. If we check it, we want to do 5 to the 2, answer minus 1. 5 to the 2, h minus 1. That's the left side, and the right side is 6 to the h minus 2. Okay. Obviously, you should get the same thing for both sides, do you? Excellent. All right. Is that the last example? Now, you try one. Quick, please. What should we do? You have room for this? No. There. You don't have room. Whiteboards or paper? Whatever you want to do. Whiteboards or scratch paper. Show me your answer when you're done. Here's paper, here's scratch paper, here's markers if you want to do whiteboards. Anybody wants to do it on the smartboard? Cool. Demonstrate that you can do this. Okay, we have about 7 minutes. That should be enough. I better do this myself. And when you're done, there's Cool. Thank you. Oh, here's your slides. Cool. Thank you. Thanks.
I did it from the
Right there. Yep. So this is the right. So this is supposed to be Wednesday, really long, but I got 80 done and I think 80 done and then stopped about those stations. After the first 6 each one, really. Okay. Yes, sir. Okay, so right here. Yes, sir. There's two cycles there. Hi. Yes, ma'am.
I have just one question.
Okay, hang on. There's three. Let's write the three, then the number four, then. Okay, and then one more four. Okay. Now. Yeah, move the X together on this side. Let me see what you got.
Okay, so for you, 18, isn't it minus 2 stars?
No, that's negative numbers, that's positive. Okay, let me, yeah, sorry, you guys think good. Thank you. First second over there. Hi. Okay. So, so you, okay, why is this, just calculate plus 1, that's fine. Here, oh, sorry, here it is. Thank you, and my keys, thank you.
I put them under.
Oh, thank you, that's good. Thank you.
Can I have a sheet?
Yes.
I finally did it.
All right.
I don't know where you messed up.
I don't know if I can help you.
Well, yeah, I'm waiting to hear back from the bell and landed on my foot. I'm thinking like, oh, I was sleeping and it's kind of like, it's really funny. I didn't watch it, it really hurt my foot. And then I tried to have to cross the head of the Thank you.
You're welcome. Have a great day.
Yes, thank you. I want to get a set.
Go get my bottom row braces. This is when I'm gonna start wearing bands.
Take it back. Have a lovely day, people. Okay, we need to get rid of this. Stop.